So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as Fundamental Operation of GIS. So till now we have already discussed in the previous lecture about digitization of GIS, different types of data, spatial data, non-spatial data, data input methods, what are the different input methods, how we can input the data. So in the previous lectures we have already discussed about the input methods like how we can input the data like spatial data and non-spatial data, and then further how we can use the data in the GIS process. Like input methods we have learned like keyboard entry, manual digitizing or automatic scanning and all that all we have discussed before. And in the 2-3 lectures we have already discussed so many times about the spatial and non-spatial data which to be entered in GIS. Now here in this lecture we are going to know what are the different operations of GIS. Operation in sense, what kind of operations we can do, what kind of editing we can do, what kind of analysis we can do, and what are the different utilization of the GIS software that we are going to learn today. So let us start this lecture today. So with this fundamental operations of GIS. So in this we have reclassification, we have different methods we have identified here, like reclassification, overlay operations, distance and connectivity, neighborhood characterization. So this all we will be discussing. So before that, let us see what are the fundamental operation of GIS. So it is like classes of operations performed via GIS have been categorized as a map algebra in which context the primitive operation of map analysis can be seen as analogs and traditional mathematical operations. So analog, if you remember what is analog, analog is the analog data is the paper format map. Okay, paper format map. So this paper format map, how can you convert it into digital format? First you have to convert this data to the digital format, then only you can work with GIS. So operation in GIS when it is possible when the data is in the raster format. Okay, raster format, or it should be in the digital form. So once the data is in the digital form, then only you can use the data in the GIS process, and then only you can work with the operations into the GIS methods. Now the classes of analytical operations are divided into, so what are the different classes we can talk about? The different classes of operations in GIS we have here is reclassification, overlay, distance and connectivity, and measurement and neighborhood characterization of the data. So these are all operations in GIS we'll be using in the process. So if you see here in this slide, we have the fundamental operations can be identified as follows, that is reclassification, overlay operations, distance and connectivity, neighbor and characterization. So these are the 4 classes we just classify the operations in the GIS. So these are all broad classification. You can see it as it is broadly classified for the operation process. Okay, for the operation processes. So let us start with this reclassification. What is reclassification? We'll get to know. So reclassification is the operations transform the attribute information associated with a single map coverage. Reclassification means, for example, you have a map here. So this is your map. So in a single map, we have different features like we can say we will classify broadly as settlement. Okay, settlement, or we broadly classify as land use. So in settlement, we can just reclassify as residential area, commercial area, okay, commercial area, industrial area. So these all classification can be declassified. So this is classification 1. So this is, under this we have classification 2. So this is how we reclassify it. First we classify into settlement. So settlement is the first one, and this is the Under this we have the second level, which is classified as residential area, commercial area and industrial area. So this further, if you want to classify the land use, so land use is the first classification. So under this, if we classify the land use, it can be transport or constructed land, or we can say residential area, or you can tell about agricultural area. So this is how we reclassify. So in GIS, what we are going to do is, first thing is broad classification. Okay, so broadly classification is done. After this broad classification, this process is done. Again, the level 1 and the level 2. So this is how the classification operation we do. For example, here you can see here reclassification operation in GIS. So this is a satellite data which is reclassified here. So these are the old values. You can see here value is given here. So after the reclassification, the values are given 1, 2, 3, 4, 5. So we are just classifying this to reclassification here. So converting this image 1, now here image 2. So this image 2 is reclassified into different colors and named as 1, 2, 3, 4, 5. Right? Now here you can see this is the old values. So these are the default values given by the computer system. Now here one more, if you see, we have here a base raster. So base raster we have, if you can see here, we have 3, 20, 20, 12. So what are these? So these all are DN numbers, we can say. DN numbers. So what are DN numbers? DN numbers are digital numbers. Okay, digital numbers. So these digital numbers, after the reclassification, you can see here that is converted. These are the old values. So 1, 2, 3. 1, 2, 3 is converted to 5. So 1, 2, 3 converted to 5 means wherever you see 1 here, 1 here, 3 here, 3 here. So old values you can see here between 1 to 3. That means the values between 1 to 3 is converted to 5. So now wherever you see 3, 3, 1 or wherever you see 3, that is converted to 5, 5, 5. Okay. Now values 3 to 7 is also converted to 3. 3 to 7 is converted to 3. Now you see here 3 to 7, this 3 is converted to 7 is converted to, you can see here, to 3. Okay, 7 is converted to 3. So this is how the reclassification. So this is the input file. And after reclassification, this is the output file. So this is how the reclassification is done in GIS process. Now you can see here reclassification of land use and land cover data. So land use and land cover data. So this is the area, this entire area is land use and land cover. Okay. So it is reclassified here into different classes, you can see here. So this background picture, what you can see the image here, it is reclassified here. So this is like, you can see here, it's a river and here you can see different vegetation. So the classification is given in the image. It is just colors are assigned to each of the classifications. It is classified and the colors are assigned to the each classification here in the image. So classification of basic image to the reclassification. That means the actual image, how it looks like, that will be reclassified into different further classifications, and that classifications will be converted into different feature classes, right? So here we can convert here into different patterns as per the requirement that is classified in the image. Now let us know about this overlay operations. So what is overlay operations? So overlay operation means overlaying the image. For this, for example, this is the image. This is the image. So if you want to overlay this image, this is the second image. This is the third image. So image 1, 2, 3, 4, 5. Okay. So there are different images here. So these all images are clubbed together and formed as a map. So one over the other, if you overlay the map, so this all map together, it is converted as map. So involves the combination of two or more maps according to the Boolean conditions and may result in the delineation of new boundaries. So this is like result of the combination of maps. So if you combine this all maps together, then it will form a single map. So this is how I was telling you about. So this is your real world data, you can say. It's a real world data. So this real world data is converted into different layers. Okay. So this is layer 1. This is layer 2. This is layer 3. This is layer 4. This is layer 5. So we have 5 layers here. This 5 layers, if we club together, then we can get a single map. So this real world map is the real world data, like it's a actual image. Okay, actual image formed by the just converting into different layers. Okay, so different layers, what we have, layer 5 is land use, layer 4 is elevation, layer 3 is parcels, layer 2 is tweets, and layer 5 is customers. So you have 5 layers together. So these all layers combined together, if you form, you will get a final map. So overlay one over the other. You can just overlay the different maps on the one over the other. So you can just separate the map. So this map can be separately, different map, map 1. This can be map 2. This can be map 3. This can be map 4. Can be map 5. So map 1 plus map 2 plus map 3 plus map 4 plus map 5. What we will get? Combination of maps. So finally we will get a final output of the map. Okay. So this is how it is working. Like layer wise means we can just overlay the maps one over the other. Once you overlay the map one over the other, finally you will get a final output of the map. Okay. Now overlay operation combines the geometries and attribute of two feature layers to create the output. So what it does, it combines the geometry and the attributes. So this is having a different geometry. This is having a different geometry. All are having a different geometry. So what it does, it combines all the geometry together. It combines the attribute for the feature layers to create the output. So the geometry of output represents the geometric intersection of features from the input layers. So each feature on the output contains the combination of attributes from the input layers, and this combination differs from its neighbor. Now feature type and overlay. So in GIS we have feature type and overlay. So feature type overlay features, what type of features we have? Point, line, polygon. So these are the features we have here, right? Point, line and polygon. These are the features we have. Now overlay operations can be classified by feature type into point in polygon, line in polygon, polygon on polygon. So you can just combine all the overlay features, like first thing what we can do is point in polygon. For example, this is the polygon, you have a point, you can put the point here. So final the output will be, there will be a polygon inside, the point will be inserted. Line in polygon means you can just put the line in the polygon. Polygon on polygon means, suppose this is the polygon, you can just put the polygon over this. This is how point in polygon overlay, the input is a point layer, the output is also a point layer but has a attribute data from the polygon layer. Suppose this is our layer, right? So here we have point here, point 1, point 2. Now plus A and B, this is polygon, and this is point. Okay, this is point. This is polygon, this is point. So if you combine these two, what you are going to get? If you combine these two, so you are going to get a polygon. This is a polygon. Along with the polygon, you are getting 1 here, 2 here, A here, B here. Okay. So this is the overlaid map, and final output. Okay. So this is how we can just overlay in the GIS. This is the operation we can do. Now see here in this figure we have line in polygon. So first one is line. So this is your line. Right? Now you have a polygon. So this is your polygon. So in your line you have 1A, 1B. Now after the final output is line with, this is the line with polygon. Okay. So final output will be line with polygon. So this is how we do the overlay process. Now polygon on polygon. Now you have a single polygon here. So polygon on polygon. So how it happens? So this is, we have two polygons here, polygon 1, polygon 2. We have a two polygons here plus AB. Second polygon is AB and first polygon is 1, 2. So if you combine these two, combination of 2. So what is the output? So this is the output. So what you have? This you have overlaid on this. So finally what you got? 1A, 1B, 2A, 2B. Okay, so this is how we get. So the two layers of overlay have same area extent. The output combines the geometry and the attribute data from the two layers into a single polygon layer. Now coming to this distance and connectivity. So what is distance and connectivity? So measurement include both simple measure of interpoint distance and more complex operations such as construction of zones, increasing transport cost, away and specified locations. Now if you talk about this complexity or connectivity, so connectivity when you're talking about, we are talking about the transport. Okay, this is the transport system like this you have. So this is connection you have, transport system connection you have. Now this connectivity is the complex operation. Okay, operation. So this transportation will be easily, you can just do the distance and connectivity because all the transport will be connected to each other. So one road is connected to the other road, so that all transportation you can just show through this distance and connectivity. So it will tell you about the, like this, we have here highways, quantities. So highway we have backside, we have different countries, and in between you can see these lines. So these all lines are highways. So these highways are connected to each other. Okay, connected to each other. So you can see here road 1 is connected to, this is road 2 for example. So these are all connected to each other, so that the map will be, the operation is like distance and connectivity. It shows the distance as well as the connectivity. So it will show this road connected to, you can see here this road is connected till here and the second road is connected till here. So this all connectivity, it will show different kinds of connections, different kinds of connectivity of road on transportation. This kind of operation we can do in GIS. Okay, we can just connect one road to the other road. You can connect a railway network to the transport, like road networks. You can overlay the road network over the railway network. So the actual real world image, how it looks like, we can just show all the connectivity in GIS process. Okay, so this is one of the fundamental operation you can do in GIS. Now coming to this neighborhood characterization. So neighborhood characterization involves the values to a location both summary. Mean the measure of variable includes smoothing and enhancement filters. So neighborhood means you should, it's like around a feature, what kind of feature it is. For example, you have a forest boundary here. So this is a forest boundary. So around this forest boundary, what is this? Neighborhood. So it's like knowing the it's like knowing the neighbor of the particular feature. So it involves the values to a location, both summary and mean measures of variable include smoothing and enhancement filters. Sequences or such main manipulation operations have become known as cartographic modeling. So neighborhood operations consider the characteristics of neighboring areas around a specific location. So it will tell you about the neighbor areas. As I told you, it will tell you about the neighbor areas, about the specific location. So what is the specific location around the area? That all it will show you with the help of this neighborhood characterization. For example, your site location is, suppose this is your site and here is your site location. So site location, around this site location, what are the features available around this? So in this, you can tell about 10 kilometers buffer. What are the features available? Okay, so that all information it will give, because this is the site location. Out of this site location, it will tell you about the information about the different neighborhood characteristics around that particular point. So the principle here is to find out the characteristics of the vicinity, and here called neighborhood of a location. So what is a neighborhood of a location? So finding the characteristics of the location wherever it is located. So many suitability questions, for instance, depend not only on what is at the location, but also what is the nearby the location. So what is there in the location, near the location? So that not only depends it it's not only depends on where is the location, but what is near. So what is near around the location, that also should be clear. So for example, here we have this neighborhood characterization. So this you have agriculture, barren land, you have a brush or transitional, built up, forest, water, wetlands. Okay, so when you talk about this built up, so you can see here this orange color. What is this? This is a built up land. Okay, so for this built up land, what is the neighborhood? What is the neighborhood here? So this built up land, you have a neighborhood of forest and water. Okay, so neighborhood will be forest. So here is the forest, you can see, or this portion is agriculture. Even you have agriculture, right? And you have water. So you have water here, agriculture here, water, forest. So these are all your neighborhood characterization. Neighborhood characterization. So around this feature, around this built up land, so you have these all features around your built up land. For example, if you want to take as wetlands, so wetlands is the, you can see here the darker portion, this wetland, this is the darker portion. So this area comes under, you can say, wetland. Now for this wetland, what is the neighborhood for the wetland? For neighborhood for the wetland, we have, you can see here, this is the agriculture, and you have neighborhood around, you have forest, and you have small built up land. So these are all the neighborhood. Okay, neighborhood. So for this wetland, you have neighborhood of agriculture, forest, built up land. So these are all neighborhood for the forest. Same the way if we talk about this brush or transitional, so it's a very few you cannot even see in this image. So it's a very small portion of the image. So when you talk about this major part is the forest. So this all around we can see here. This is all forest. So forest neighborhood is what? Forest neighborhood you have some part of the agriculture, some part of the water body, some part of the built up land. It is having the neighborhood. So around that particular feature, around that particular object, what kind of features are present? So that all comes under this neighborhood characterization of the image. So fundamental operations, as we have studied in this, we have learned, we have four types of characterization. So first of all, what we have seen is reclassification. So what is reclassification? Classifying the image, reclassifying the image. For example, the computer system will give you the automated digital numbers. So that digital numbers, if you want to reclassify, you can just reclassify into different digital numbers, or if you want to just change the colors of the each particular feature, that can be reclassified. For example, if you have a feature type, like if you have a settlement or if you have a built up land, so broadly we can classify the built up land, and later on if you want to go with the more reclassification, so that built up land can be classified as you can say that residential, commercial, industrial, or any kind of construction land you can tell about this reclassification. Then you can see about the overlay. So overlay operation is the very important in GIS process. So overlay operations, when it is possible, when the GIS is the having some georeferencing, or it is having some latitude or longitude, or some kind of location, if it is assigned to the layers, and then you can just go with this overlay operations. You can just overlay any feature on the other feature. For example, if you have a point feature, you can overlay the point feature on the polygon feature. You can overlay line feature on the polygon feature. You can overlay polygon feature on the polygon feature. So these are all such type of operations we can do in GIS. And further, you have this characterization of networking. Networking is what? Networking is very important when you go with the transportation. The networking is very important. Networking is very important. So for transportation, for showing the distance and connectivity, we have to just look with this transportation network, or something like connection of this, you can say distance and connectivity, we say, to increase the transport and the cost from the specified locations. If you want to know, that all can be done in the GIS operation. Next, so finally, if you talk about the neighborhood operation, this is also a very important operation in GIS. So once you have a particular location, like just now I told you about the particular site, wherever your site is located. So which type of feature it is, which type of site it is, based on the site, what are the neighboring features around that. So neighboring features can be for water body, it can be vegetation. For water body, it can be forest, or something like settlement area. Or if it is a forest, suppose forest is the main location site. So for forest, what is the neighboring features? So the neighboring features for the forest can be built up land, commercial land, or residential land. This all can be done in the GIS process. So these are the four major things which we can do in the GIS as a fundamental operation. So this is the fundamental operation of GIS. So I hope you understood about this fundamental operation of GIS. So basically with these points, we are able to construct our own map. We can create from raster to vector, and you can just generate your own map based on this fundamental operation in GIS. So these are the references you can just go through while if you want to know about this operations in GIS. And GRD book, which is already I refer in all the lectures that this book is very important for the what you can say, if you want to know about the GIS, or else if you want to know about the remote sensing process, you can just go through this book. Or You can just go through this link for finding out the more content. Also, this book is very important for the GIS analysis, you can say, analysis or operations. You can just go through refer this book for this GIS operations. So to find out this more content about this. Okay. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.